Before any Great Pyramid stood at Giza, Egypt already changed. Kings of the early Old Kingdom no longer settled for mud brick and small tombs. They pushed towards stone because stone promised permanence and permanence supported authority. That choice carried a hidden cost. Stone was heavy, stubborn, and unforgiving. If a wall leaned, it did not bend back. It failed. Building in stone demanded new thinking, or it demanded surrender. The first steps looked simple, then proved difficult. Builders stacked limestone in low, thick forms, learning how weight traveled downward and outward. They discovered that flat roofs cracked unless loads were managed, and that corners slipped if courses were uneven. Each mistake taught a rule. Stone had to be laid level, joints had to meet cleanly, the base had to stay true. These were not artistic choices, they were survival choices for the building. Out of those rules came a new idea. Height could be controlled by shape. A mound of stone slumped, but a stepped mass held itself better because its weight pressed inward. That principle made a real pyramid imaginable, not as a sudden invention, but as a series of solved problems. Each experiment pushed confidence a little further. More stone, higher rises, tighter alignment. Egypt moved from building with stone to engineering in stone. The Great Pyramid waited on that shift. The breakthrough did not begin with a pyramid, it began with the block. Builders learned that limestone was not just something to admire in small pieces, but something to command in huge ones. In the quarries, they stopped relying on luck and started relying on method. They cut straighter faces, planned the size before the stone moved, and produced blocks that matched each other. Stone started behaving like a standard unit. Then came the real test, movement. A block that weighed tons meant nothing if it could not travel. Teams organized hauling as a routine, not a stunt. They prepared paths, timed the pulls, and managed friction and balance until transport became predictable. This changed everything. Once delivery could be counted on, sites could be fed continuously. Construction stopped waiting for stone. Stone arrived on a schedule. Finally, they had to place the blocks without shattering the plan. Setting large limestone at scale demanded control at the last moment, aligning edges, keeping courses level, and adjusting fit before the weight locked it in place. Small errors multiplied fast, so builders tightened their process and repeated it thousands of times. That repetition was the miracle. Stone shifted from rare material to dependable technology. Once stone construction scaled up, another problem surfaced: shape. A pyramid only worked if every face rose at the same angle and met at one point. Small errors multiplied fast. Surveyors responded by tightening the geometry. They used simple tools: straight edges, plumb lines, measured chords, and repeatable checks. The goal stayed practical: keep each course square, keep corners true, and stop drift before it became permanent. Then came orientation. A giant pyramid needed to sit on the land like a compass needle, aligned to north, south, east, and west. This was not decoration. It set the whole grid that every block followed. Surveyors watched the sky and tracked predictable motions of stars, using sighting lines to mark a true north reference. From that line, right angles could be laid out, and the four sides could be locked in. The surprise was the precision. With careful repeats, measure, sight, mark, recheck, the alignment could reach accuracy that still looked deliberate today. Once the base directions were fixed, the pyramid's geometry became easier to control because every new layer inherited the same straight plan. This method turned a massive build into something that stayed coherent from first block to last. It made the impossible feel manageable. Khufu ordered a pyramid at Giza, and that decision changed everything. This was not a temple added over time, or a tomb improved by later hands. It was a single enormous target fixed in the king's lifetime. To meet it, the state had to act like a machine. Orders travelled outward, plans came back in. Stone, tools, food and people all had to arrive on schedule, or the whole project stalled. An organised workforce took shape, not as a random crowd, but as roles that matched the job. Some cut stone, some hauled, others shaped, measured, repaired gear, or kept records. Crews had to be rotated and replaced without breaking momentum. That meant management, not just muscle. Work gangs needed supervisors, and supervisors needed clear targets. The pyramid turned labour into a system, and the system had to run month after month. Feeding that system became its own national operation. Grain had to be collected, stored, and moved to Giza in steady waves. Water, meat, and other supplies followed the same logic. Meanwhile, quarry output had to match the building pace, so block deliveries met the timetable of laying courses. One delay rippled into the next. So the state built time itself into the plan. The pyramid rose because Egypt learned to coordinate. Construction began where failure was easiest to hide and hardest to fix: the ground. Before a single course rose, engineers had to turn uneven bedrock into a dependable platform. High spots were cut down, low spots were packed and dressed. The aim was simple but unforgiving. Make the base behave like one flat surface so the weight above spread evenly instead of hunting for weak points. They could not trust their eyes, so they built a reference they could trust. A baseline was set, straight and repeatable, and every measurement grew from it. Lines were carried across the rock to form a grid, like a map laid onto the ground. Each square told crews where a block belonged and how it had to sit. Without that grid, small errors would have drifted, and drift would have become tilt. Stability had to be designed into the first layer because later layers only multiplied whatever was already wrong. So each block of the foundation course was checked against the grid and against its neighbours, not just for position but for contact. Gaps meant movement, movement meant cracks, and cracks meant collapse years later, after millions of blocks had already committed to the mistake. This was where the pyramid was decided. Once the base stayed true, the problem changed. Now every block had to rise. Gravity stopped being an abstract force and became the main opponent on the worksite. Builders answered with ramps and hauling, not as a single trick, but as a system that could repeat all day. Stones slid on sleds, pulled by teams in rhythm, while the ramp gave the load a longer, gentler path upward. But height punished every small mistake. As courses climbed, any uneven layer below turned into a bigger error above, so the lift had to stay steady and the stonework had to stay tight at the same time. Ramps shifted, extended, and steepened as needed, and hauling paths got rebuilt again and again. Each new level demanded fresh control. Lines kept straight, joints kept close, and blocks placed without drifting out of square. The real breakthrough came when this stopped being heroic and became routine. A ramp was not just a road, it was a moving tool that rose with the pyramid. Teams coordinated the pull, others guided the sled, and setters waited at the top to lock the block into its course before the next load arrived. Course by course, the same method repeated, and the structure climbed, because the process stayed predictable. Inside the rising pyramid, a new problem appeared. A solid mound could simply stack upward, but this one needed empty spaces, passages, a burial chamber, and rooms meant to manage pressure. The moment builders cut a void, the weight above stopped behaving like a simple pile. Tons of stone pressed down, searching for the weakest point. One misjudged span could collapse, burying the work and wasting years. Engineers responded by treating weight like something that could be directed. They did not just build walls, they built paths for force. Blocks over openings were arranged to bridge gaps, then layers above were shaped to push the load outward and away from the void. It was careful, staged work. The chambers could not be finished at the end. They had to be built as the pyramid grew, step by step. That led to the most delicate innovation, relieving structures. Instead of trusting one ceiling to hold everything, they stacked multiple layers above key spaces, each one taking some pressure and passing it along to stronger masonry at the sides. The goal stayed simple and ruthless: keep stone from crushing stone. When it worked, the pyramid could rise higher with confidence because its most dangerous spaces stayed stable. The hard part no one saw from a distance came last. After the core rose course by course, teams had to turn rough stacking into a finished shape. They brought in fine casing stones, cut to tight angles so they locked together as they climbed. Each block had to sit perfectly because a small error low down spread upward fast. Finishing did not forgive mistakes. It exposed them. To make those outer stones meet cleanly, workers dressed surfaces again and again, trimming high points and filling tiny gaps until the face read as one plane. The goal was not just strength, it was a precise geometry you could read with your eyes and hands. Then the last steps sharpened the effect. Corners were corrected, edges were straightened, and the outside became a continuous skin that controlled rain, wind, and time. But the pyramid did not stand alone, and completion meant the whole complex worked as a single route. Causeways linked the river edge to the pyramid plateau, turning delivery roads into ceremonial paths once hauling ended. Temples at each end organized offerings, storage, and ritual movement, giving the monument an operating system, not just a shell. When those connections were finished, the project stopped being construction. It became performance. Once the builders finished and the rituals ended, time started doing its own work. The pyramid stayed, but its purpose began to blur as dynasties rose and fell. What had been a sealed royal tomb gradually became a landmark people reused and reimagined. The smooth outer skin did not last. Later generations treated the casing as a ready-made quarry, and each missing stone quietly changed how the monument looked and how it was understood. The stripping happened for practical reasons, not ideology. Fine limestone, already cut and fitted, saved enormous labour on new projects, especially when cities needed repairs or new buildings. As those blocks disappeared, gaps opened and edges stepped out, exposing the rough core that earlier workers had meant to hide forever. Around it, the ground also changed. Paths shifted, debris piled up, and nearby structures decayed or were rebuilt so the pyramid slowly lost the context that once explained it. With the surface altered and the original complex less readable, new stories rushed in to fill the silence. Visitors saw a giant shape without the old instructions for what it meant, and they supplied their own answers. Some treated it as a relic of unmatched royal power. Others saw a riddle built by forgotten knowledge. The more its original finish vanished, the more the pyramid turned into a symbol that belonged to everyone, and a mystery no single age ever fully closed. Modern archaeology did not treat the Great Pyramid like a legend. It treated it like a worksite with evidence still trapped in stone. Excavations traced worker villages, bakeries, and storage areas, showing how food, tools, and labour had been organised day after day. Small marks left by crews inside the structure added another layer. Teams had been named, assigned, and managed. The pyramid stopped being a miracle. It became a system. Engineering tests then pushed the questions further. Researchers measured surviving blocks, checked joints, and studied the way loads would have moved through the core and above the chambers. Replicas of ancient methods were tried under controlled conditions, not to prove that anything was easy, but to find what was repeatable. Results narrowed the range of possible ramp designs and hauling speeds. Some popular ideas failed fast. Others matched the numbers. Scanning technologies changed the scale of what could be known without tearing anything apart. Mon scans and other non-invasive surveys mapped density changes, confirming known spaces and hinting at unexpected voids. Each new dataset forced older explanations to tighten or break, and the contrast stayed sharp. Modern teams had instruments, computers, and models. The original builders had stone tools, rope, sledges, and coordination strong enough to turn plans into reality.